Let's solve this LeetCode remove duplicates from a sorted array. So given an integer array nums, like how we have here, we want to remove the duplicates such that each unique element appears only once. And the order of the elements should be kept the same as well, and then we want to return the number of unique elements inside of nums. So if we look down here, we have something that's going to test our code. We also have some example, input, outputs, and explanations. There's going to be underscores in these examples, and that's just because in some languages, like in Java, in which we're coding now, or in C++, you can't resize an array. So there'll be either some extra space left over, or just some other garbage variables. So we don't need to worry about these. What we do need to worry about is that everything here is in sorted order. So if we look at case 2, this is a perfect example that we can model our code after. First, we know that we need to return a unique variable. So let's make a unique variable. It's going to be an integer. We'll call it result, and we'll set it equal to 0 initially. Once we come down here, we can return our result. So that's going to be our starting point. Now is where we know we need to go through every element inside of our array, because we need to examine every element. We're going to say int a is equal to 0, and we want a to be less than our nums. And then we have a++. This is a basic header for an array. I did forget to do nums.length, which is important because we want to run it for the length of our array. I'm going to start a at 1. Typically when you use like 2 pointers, I will, because you can't really look at the next value, you can only look previously, because once you get to the end of this, you might get an array out of bounds error if you do like a +1 and you want to look at that index. So we're just going to look at 1 before this index. To do that, let's make an if statement inside of here. We'll say if, and we know we want to increment our result, which is the unique value, every time they do not equal each other, because this means we've come across a new unique element. So if our nums at our current a does not equal to the nums at our a minus 1, so that's the previous value, we're going to be inside of this if statement. First, we're going to want to increment our result, so we'll have result plus plus, like this. Now that I'm thinking about it as well, if we have at least one value in here, our result is going to be unique. And so let's start this off at 1, and then we can have a check here and return if this is equal to 0. So if nums.length is equal to 0, that means we have nothing in here, and we should just return 0. We don't need to go through all of this. If we have anything greater than 0, we'll have at least one result. Now, inside of here is where we're going to want to examine this. So the first time we run this, we're going to say a is equal to 1. Remember, because we want to look at the past value, so we're also going to have is not equal to 0. Both of these are based off of this a. We can see 1 is equal to 0, so we're not going to do anything here, but we are going to need to switch this out. So in the next pass, we have 2 and 1. We can see index 2 does not equal to index 1, so we can go inside of here, and we should replace this value with this value. It's a good idea. So inside of here we can say nums, and we need to replace the first index with the second index part. Well, the first index we can do a minus 1, but this is also going to be based off this result here. So we can put result in here, and we can say that the index at result is now equal to nums at our current index that we're looking at. And then we're going to update our result afterwards. So this is now going to hold 2, and this should now go down to 1 because we've moved this there. Now we have 3 and 2. Once we run this again, we have 0, 1, 2, 3. This is the third index. 3 and 2 are the same, so we're not going to do anything here. Oof, let's run this again. This is going to be a 4 and 3. So 0, 1, 2, 3, 4. 4 and 3, they're different. And since they're different, we're going to be inside of here. Let's see, we should update our nums at result. So nums at index 2, 0, 1, 2. That's perfect. It's going to update this one with our current a value, which is going to be at index 4. So 0, 1, 2, 3, 4. So 2 is going to come and replace this 1 right here. We're moving this down. Let's run this again. Also, result is now 3. So this should be 5, and this should be 4. 0, 1, 2, 3, 4, 5. 5 and 4 are the same. So we'll do this again. Well, this is 6, and this is 5. We were last here. And now we can see 6 and 5 do not equal. So we'll be inside of this if statement. And so we want to set num's result, which now holds the index 3, 0, 1, 2, 3. It's going to be at this 1 right here. We're going to replace it with our index value at 6, which is going to be the 3. So this is going to get replaced with a 3. Now we can run this again. This is going to be 7, and this is going to be 6. So we have 0, 1, 2, 3, 4, 5, 6, 7. 6 and 7 are both the same. So we run this again, and we're going to have 8 and 7. 8 and 7 is just going to be these next two. We can see that they're different, so we're going to go inside of this if statement. We're going to update our result at index 4, 0, 1, 2, 3, 4, which is this 2. We're going to update it with the value at index 7, so this 4 is going to be here. We don't need to worry about the rest of these because, again, we can't resize the array. It's expected that our testing code right here, the judge, should be able to do this, basically ignore all these. So with this done, we're returning our results. Let's try to run this and see if we passed our test cases. It's going to give an invalid test case though for that because I messed with it and it's not in sorted order, and the test cases need to be in sorted order. So I also forgot to close off this method right here. We'll do one more bracket, and we passed case 1 and we've passed case 2. I edited case 2, but if you refresh your LeetCode, you'll be able to get your original test cases that it came with back. So we can run that again. It's accepting both test cases, and then we can just submit it from there. And we've done it in 1 millisecond runtime. So that's going to be the code. And that's how we would solve remove duplicates from sorted array with LeetCode.